We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Good morning, friends. In today's lecture, we learn about the air-water system. Okay, in all air system, we use air as a working medium, and in all water system, we use water as a working medium. In this type air-water system, we use air and water both as a working medium. Okay, so in air-water system, both air and water are used for providing required condition in the conditioned space. The air and water are cooled or heated in central plant. Here, both air and water are cooled in central plant. So we use the both two separate air conditioning plant, for one for air and one for water. Here mainly cooling or heating is produced by the air, so it's called the primary air, and the remaining heating or cooling is provided by the water, so it's called the secondary water. The complete system consists of central plant for cooling or heating of water and air, and ducting system with a fans or conveying air, then water pipeline and pump for conveying water and room terminal. So it's a combination of air and water system. Okay, so we use the fan and blower for transmitting the cold or hot air, and we use the pump for transmitting the cold or hot water. Okay, so here we have two air conditioning plant, one for air and one for water, and two separate distributing system for each. Okay, and the room terminal may be in the form of fan, coil unit, and induction unit or radiation plant. Okay, so we use any of this. Okay, let's see the schematic diagram of air water system. Okay, here as I told that there are two separate central air conditioning plant, one for the air and one for the water, and two separate distribution system. Okay, here we use the air fan or blower to transferring the primary air, and pump to transferring the hot or cold water. Okay, then here there is one room unit is provided. In the room unit there are primary air is enter, and also the secondary water is enter. So here in the room unit there is a heat exchange take place between the room air and cold or hot air and cold or hot water. Let's see how it works. Okay, here the secondary air or room air is come to the room unit. Okay, so first come in contact with the primary air. Here there are the three functions of primary air. Okay, primary air first, it's taken care about the all the latent heat. Okay, all the latent heat is uh, taken care by the primary air. Okay, we know that there are two types of load: sensible load and latent load. Okay, so together all the latent load are taken care by the primary air. Then second one is some part of the sensible heat is taken by the primary air. Okay, and the third function of the primary air is to provide the proper ventilation. Okay, so here there are the three function of primary air. Okay, when the surrounding air is come in contact, it's all the latent heat load is transferred to the primary air. Then and in from the total sensible load, there is some part may be transferred to the primary air. Okay, then the air is come in contact with the secondary water line. So the secondary water line taken care by the remaining sensible load. Okay, so all the sensible and latent load are transferred to the primary air and secondary water line. Okay, so here we transfer the total latent heat load to the primary air, and some part of the sensible heat load to the primary, and then the remaining sensible heat load is transferred to the secondary water line. Okay, so like this it's work. Normally, a constant volume of primary air is supplied to each zone depending upon the ventilation requirement and the required sensible cooling load capacity at the maximum building load. So the constant volume of the primary air is depend on two parameters. First is ventilation requirement into the room. As I told earlier, that the ventilation is provided by the primary air. That is the function of primary air. So that according to the ventilation requirement, we we maintain the constant volume of the primary air. And the second one is the required sensible cooling load capacity. So according to the ventilation requirement and sensible cooling load capacity, we decide the constant volume of the primary air. Okay, here we talk about the summer air conditioning. Then the primary air is cooled and dehumidified in the central plant. As we know that in summer air conditioning requirement processes cooling and dehumidification. Okay, so the primary air is cooled and dehumidified in the central plant. Then it is transferred to the condition space by using the distribution system. Okay, so that it can offset all the building latent load. Okay, so the all the latent load is taken care by the primary air. There are no latent heat load is transferred to the secondary water. Okay, the chilling water is supplied to the condition space to partially offset the building sensible cooling load only. So we transfer only sensible load to the water line. Since the chilled water coil kept in conditioned space has to take care about the only sensible load, condensation of room air inside the conditioned space is avoided. Okay, so the drawback of the all water system is if we transfer the sensible and latent heat load to the water system, then there may be problem of condensate, or so we require to arrange a separate system for the drain water. So here in this type we transferring the only sensible load to the water line, so there are no any problem of condensate water. Okay, so there are no any problem of condensation, so we not required to arrange any drain system in this type. So since the chilled water coil kept in condensation space has to take care only sensible or condensation of room air inside the condensation space is avoided, thereby avoiding the problem of condensation drainage and related problems in conditioned space. As mentioned, the primary air takes care about the ventilation requirement of the conditioned space. Hence, unlike in all water systems, there is no need for separate ventilation system. Okay, in all, but here the ventilation is provided by the primary air, so we not need separate ventilation system in this type. Okay, in winter, moisture can be added to the primary air in central plant, and hot water is circulated through the coil kept in the conditioned space. Okay, in winter, we know that the process is requires heating and humidification. Okay, so here the moisture is added by adding the moisture in the primary air. Okay, and heating is carried out by hot water transfer into the water line. Okay, so like this we achieve the heating and humidification in air water system for winter AC. Okay, the secondary water line can be of 2 pipe, 3 pipe, or 4 pipe type, similar to the all water system. Okay, let's see the advantages of air water system. Here the individual zone control is possible in an economic manner using room thermostat, which is controlled either the secondary water flow rate or the secondary air or both. Okay, here we control the different temperature in different zone by changing the flow rate of water or by changing the flow rate of air. Okay, so here the individual zone control is possible. Then second one is it is possible to provide simultaneously cooling and heating using primary air and secondary water. So we can achieve different cooling in one zone and heating in another zone. So simultaneously cooling and heating is possible in in air water system. This requirement is reduced as the amount of primary air supplied is less than that of an all air system. Okay, here we partially heating or cooling load is carried out by the primary air, and remaining part is taken care by the water line. Okay, so here the size of the duct is less in compared to the all air system. In all air system, we 100% load is transferred to the air. Okay, so in that type, duct size is more. Then the positive ventilation can be ensured all under all condition. Okay, so here the ventilation is provided by the primary air. Since no latent load transfer is required in the cooling coil kept in the conditioned space, the coils operate dry and life, thereby increase and problem related to the odor or fungal growth in the conditioned space is avoided. that we only transfer the sensible load to the water line. Okay, so we will not face the problem of condensation of the water. So we will not face the problem of drain water in this system. So there are no problem related to the odor or fungal growth in conditions space. Okay, the service of the inter unit is relatively simple compared to the all water. Okay, let's see the disadvantages of air water system. Okay, operation and control are complicated due to need for handling and controlling both the primary air and secondary water. Here we handle the both air system and water system, so its operation and control are complicated. In general, these systems are limited to the perimeter. So, and the third one is the secondary water coil in the conditions it can be dirty if the quality of filter used in the room unit is not good. Okay, if we not use the good quality of filter, then the dirt is entered to the room unit and it's stuck onto the water pipe. Okay, so it increases resistance. Okay, since a constant amount of primary air is supplied to the conditioned space and the room control is only through the control of room cooling or heating coil, shutting down the supply of primary air to unoccupied space is not possible. Okay, it means we always on switch on the primary air supply. Okay, we never shut down the primary air supply because main heating and cooling is carried out by this. Okay, so it's not possible to shut down primary air supply. If there is abnormally high latent load on the building, then the condition may take place on the cooling coil of secondary water. Okay, as we learned that we only transfer the sensible load to the water line, but if the latent load is more than the design, then some part of the latent load may be transferred to the water line. In that case, we face the problem of condensation of water. Okay, so the initial cost could be high compared to all air system. Okay, here the initial cost is high because we handle the both air and water system in this type. Let's quickly learn about the application of air water system. Okay, this system are mainly used in exterior building with a large sensible load. Okay, so this system we use when we have large sensible load. And okay, and second application is we use this system when we not require close control of humidity and conditions. Okay, so this system are mainly used in office building, hospital, schools, hotels, apartments, etc. Okay, so here I conclude the air water system. Okay, let's quickly learn about the summer air conditioning system, winter air conditioning, or year air conditioning system. In summer air conditioning, we require the in psychometric data we learned that in summer air conditioning process occur is cooling and dehumidifier. So here we decrease the temperature of air and decrease its humidity. Okay, so here the return air is come and here the fresh air is enter into the room due to ventilation purpose. Okay, so this mixed air is first enter into the filter. Okay, so filter due to the cleaning purpose. Okay, so after it pass from the clean air is come outside the filter. Okay, this clean air is transferring to the refrigerant plant. Okay, refrigerant plant is the cooling coil. Okay, here the cooling coil. Here the cooling coil temperature. The cooling coil temperature is less than the dew point temperature of the air. Okay, so if its temperature is less than the dew point temperature of air, okay, we achieve the process of cooling and dehumidification. Okay, then the cold air after passing from the refrigerant plant, the cold air entering to the heating coil. Okay, heating coil is not compulsory, but we use heating coil when we require the precise control of the temperature and humidity. Okay, after that it transfer to the conditioned space by using the fan or blower. Okay, and after in conditioned space when it is cold and humid air is entering, it absorbs the heat. Okay, then the hot air is transferred to the again transferring to the refrigerant plant. Okay, so like this the cycle is working. Okay, so here mainly achieve the process of cooling and dehumidification. Okay, so achieving cooling and dehumidification, here the main condition is cooling coil temperature is less than the dew point temperature of air. Okay, let's see the second type winter air conditioning system. Okay, in winter we require to process this heating and humidification. Okay, so here we require to increase the temperature of air and we increase the humidity of air. So in winter air conditioning, here the room air and the fresh air and fresh air are mixed here. So this mixture is added to the filter due to the cleaning purpose. Okay, after that, after this clean air is transferred into the preheater. So we here increase its temperature. Okay, after that it is transferred into the humidifier. Into humidifier we added the moisture content into the air. Okay, so this heated and humid air again then transfer into the reheater. Okay, reheater is used to precise control of temperature and humidity. Okay, after that by using the fan or blower we transferring this air to the conditioned space. Okay, when it is entering to the conditioned space, it rejects the heat to the room. Okay, then this cold air is again transferring to heating coil are closed, okay, and in winter refrigerant plant is closed, okay. So it is air conditioning system we use in all seasons, okay. So here I conclude this lecture, okay. Here we conclude our chapter air conditioning system, okay? I hope you understand all the topic.